Okay guys, welcome back. So we will proceed with the next example, which is fs is equals to 1 over s squared plus 4. Okay, so by looking at the table of the Laplace transform, this one, the general of fs is equals to Laplace inverse of a over s squared plus a squared, which is equals to sine at. Okay, so define your a by comparing the general one here with what you have here. So you know that your a is equals to 2, a squared is equals to 4, so a is equals to 2. So therefore your ft is equals to Laplace inverse of 1 over s squared plus 4. Okay, so your a is equals to 2. So supposedly you should have 2 here. So what you need to do is time by 2 and you need to divide by 2. Okay, you multiply by 2, so you need to divide by 2. So therefore this one is equals to 1 over 2 sine 2t. Okay, so the next one is, if your fs is equals to 5 over s minus 7. So by looking at this one and the table of the Laplace transform here, so this is s minus a. So you should use this one. Okay, so you know that the inverse of one over s minus a is equals to exponent at. So here you need to do something for the numerator part. Why? Because general is 1 over s minus a, but what you have is 5. So you need to factorize the constant here and compare to get the value of a. So you know that your a is equals to 7 because this is s minus, this is s minus. Okay, you have s minus a, what you have is s minus 7. So you know that your a is equals to 7. Okay, so therefore your ft is equals to, so 5 is a constant, so factorize. So actually you need to find the inverse of 1 over s minus 7. Okay, so this one is equals to 5. So 1 over s minus 7 will give you exponent. So a is equals to 7. Exponent 7t. Okay. So the next one. If your fs is equals to 1 over 2s plus 5. So now if you compare with the table of the Laplace transform that you have, there is no such function which is equivalent to this one, where this one here you have a constant in front of your s, and that constant is other value than 1. As you can see here, this is s. This is s to the power of something. This is s minus a, not ns, not 3s, isn't it? This is s squared plus e squared. This is s squared minus e squared. So it's actually this one. If you compare, the nearest function to this function, the nearest one that you can choose is 1 over s minus a. Okay, still the same as the previous example. So Laplace inverse of 1 over s minus a is equals to e at. But be careful. Here you have s minus a. But your problem is 2s plus 5. So you cannot simply write your a is equals to negative 5. That is wrong. You need to make sure that the coefficient of s is 1. Okay, because now you have 2 here. For the previous example, you don't have any problem. Why? Because the coefficient of s is 1. Okay, but as for this one, the coefficient of s is 2. So what you need to do is, you need to factorize this one, right? Factorize 1 over 2. So your ft is equals to Laplace inverse this whole function 1 over 2s plus 5. So is equals to, so as you can see here, you cannot simply get exponent because of you have 2 here. So you need to factorize 2 here. So if you factorize this value, it should be 1 over 2, isn't it? Because this is 1 over 2. Okay, so Laplace inverse 1 over, so since you already factorized 2 here, so you will have s here. But what will happen to this value? If you write s plus 5, this is wrong. Why? Because if you multiply 2 by s, you will have 2s. 2 times 5 is equals to 10, not equals to 5. So you already changed the problem. Okay. So if you factorize 2 here, then it should be 5 over 2. Okay, so that if you expand back this expression, you will get the same problem. You don't change the problem. Okay, if you don't divide by 2 here, if you expand 2 times s, you will have 2s. 2 times 5 is equals to 10. But what you have is 5. So that is wrong. So that's why you need 5 over 2. Okay, because 2 times 5 over 2 is equals to 5, which is this one. Okay, so by comparing this one and this one, so you can get your A. So generally you have s minus A, and what you have is s plus 5 over 2. So you know that your A is equals to negative 5 over 2. So therefore your ft is equals to 1 over 2 exponent, your E is equals to negative 5 over 2 t. Okay, so I recall back for this one why we need to factorize 2 here, because general is s minus a constant. The coefficient of s is 1, but what you have is 2. So that's why I factorize 1 over 2. And if you factorize 1 over 2 here, you will left with s plus 5 over 2. Okay, remember, try to multiply back this one. If you get the same problem, so what you did here is correct. Okay, but if you multiply back here and you don't get the same function as before, what you do, something wrong. Okay, something wrong for what you do. Okay, so you need to check back. Okay, so why here is 5 over 2, because when 2 multiplied by 5 over 2, then only I get 5, the same as before. If I just factorize without over 2 here, when you multiply back 2 times 5 is 10, so not equals to 5, so that is wrong. Okay, so next one, let's say you have your fs is equals to 3 over 9s squared plus 4. So here you have x squared plus a constant, and for the numerator part is a constant. So you know that you will have sine function a over s squared plus a squared. But again here, the coefficient of s squared should be 1, but what you have is 9. So you need to do something. And a is not equals to 3, isn't it? So generally, the inverse of a over s squared plus a squared is equals to sine et. So you have a problem with this value and also this one. Okay, why? Because for this one, you know, if your a squared is equals to 4, your a is equals to 2. Okay, so this is a constant, this is a constant, so factorize the constant first. Okay, then you can identify your a. Okay, so your ft is equals to Laplace inverse of the whole thing here. So now factorize the constant. So you have a constant 3 over 9. Laplace inverse. So now here you have 1 over x squared plus 4 over 9. Okay, why here is 4 over 9? Because when you multiply back 9 with this expression, you will have 9s squared plus 4. Okay, so now that you can get the value of a, you cannot simply find your a from here because the coefficient of s squared is not 1. Okay, so you need to factorize first, do some modification for this part, then only you can find the value of a. Okay, so by comparing this one and what you have here, so your a squared is equals to 4 over 9, so therefore your a is equals to 2 over 3. So supposedly this one here should be times 2 over 3, because your a is equals to 2 over 3. So if you multiply by 2 over 3, then you need to divide by 2 over 3. Okay, multiply by 2 over 3, then divide by 2 over 3. So this one is equals to 1 over 2 sine your a is equals to 2 over 3 t. Okay, how did I get 1 over 2 here? You just use your calculator. 3 over 9 divided by 2 over 3. Okay, this one, if you simplify, it should be 3 over 9 times 3 over 2. okay, because this one divide, if you change 2 times, so this one will be numerator, this one will be denominator. Okay, but much more easy, just press the calculator. 3 over 9 divided by 2 over 3, so you will have 1 over 2. Okay, so the next one is if your fs is equals to 2s over 16s squared plus 9. So by looking at this one, you can guess this is a cost function. The inverse of this one is equals to a cost function. Why? Because this is s. Why cos? Because this is plus. Okay, so the inverse of s over s squared plus a squared is equals to cos 80. Okay, so factorize the constant, then only you can find the value of a. So your ft is equals to, so what is your constant here? 2 over 16. So factorize this one, you will be left with s over s squared plus 9 over 16. So although here you have 2s, 3s, so you still can get cost function as long as s for the numerator part and you have s squared plus a constant. So you know that if you have in this form, so it should be cos. But generally for the function to be a cost function, the coefficient of s is 1. So that's why I factorize 2. Same goes for this one. The coefficient of s squared is 1. So that's why I need to factorize 16. So therefore I factorize 2 over 16. Okay. So now you will have 9 over 16. So by comparing what you have here, so you can get your A. So you know that your A is equals to, so you will compare this one with what you have here. So A squared is equals to 9 over 16. So A is equals to 3 over 4. Okay. So for this part here, if you simplify, you will have 1 over 8. Okay. Do you need to times by 3 over 4 divide by 3 over 4? No. Why? Because for the numerator part is s. For the previous example, the numerator part is a constant. That's why if your a is equals to 2 over 3, then you need to multiply by 2 over 3, divide by 2 over 3. But for this one here, the general form is s. Okay, so therefore you will straight get your answer 1 over 8 cos 80, 3 over 4 t. Okay, last one. If your fs is equals to 2 over 9s squared minus 25. So by looking at this one, you know that this one will be sine hyperbolic function. Why sine function? Because of a constant for the numerator. Why hyperbolic? Why sine hyperbolic? Because you have x squared minus a squared. Okay, so the inverse of a over x squared minus a squared is equals to sine hyperbolic 80. Okay, so therefore your ft is equals to, so factorize a constant here, 2 over 9. Okay, although here a is a constant, you just factorize if you have other value than 1, because it will be more easier for you to multiply and to divide. Okay, as you can see in the previous example, I have 3 here. 3 is also a constant, but what I did is I just factorized first 3. Okay, because you don't know yet what is your a. Okay, so factorize 3 first, then get your a, then times by your a, then you divide by your a, divide by the same constant. Okay, so the same process here. So you have 2 over 9, so Laplace inverse, so now you have 1 over s squared minus 25 over 9. Okay, so by comparing this one with what you have here, your a squared is equals to 25 over 9, so you know that your a is equals to 5 over 3. Your a is equals to 5 over 3, so should be here is 5 over 3. So you need to multiply by 5 over 3, and you need to divide by 5 over 3. Okay, so multiply by 5 over 3, then divide by 5 over 3. If you cancel out this one, so you still have the same problem. Okay, so therefore, so this one you just press your calculator. So you will have 2 over 15 sine hyperbole. Your e is equals to 5 over 3. So let me just show this one. So you have 2 over 9 divided by 5 over 3, which is equals to 2 over 15. Okay, so this is our basic function. I already shown to you many examples here, so try to take a look again at each of the following function and try to do on your own. Okay, make sure you understand this one, because when we go to the next subtopic, which is the properties of the inverse Laplace transform, you will have problem if you don't know the basic inverse. Okay, because here we are doing a reverse process. Okay, some of you might be blue. Okay, so make sure you really understand this one first before our next session, which is our next lesson, which is properties of inverse Laplace transform. Okay, so if you have any problem, please let me know so that I can guide you. Okay, thank you guys, and see you in my next video.